In this video, we are going to start with our introduction to partial fraction decomposition. So the first thing I want to do is just show how to put two rational functions, two fractions with variables in the denominator, into one fraction, okay? So if we simplify this into one fraction, what we would want to do is decide what we could get as a common denominator. So for this one, I would need to multiply by x minus 4 on both top and bottom. So we want to get a common denominator because in order to add fractions, you need to have a common denominator. So then on this side, I would need the x plus 5 factor. So then we would multiply that to both top and bottom, because that's just like multiplying by 1, which doesn't change the actual value of each fraction. So then in this one, so now you're going to simplify, okay? So in this one, I would distribute the 2 into both of these. So I would get 2x minus 8. And then I'm actually not going to multiply out the denominator. I'm just going to leave it as x minus 4, x plus 5. If I needed to combine them, I would. So when we're adding fractions, you're going to add the tops when the bottoms are the same. So we won't actually need to have the bottoms multiplied out. So in this second fraction, I'll distribute the 3 in. So we'll get 3x plus 15. And then that x minus 4, x plus 5 in the denominator. So now that you can see that these denominators are identical, you can just add the tops. Okay, so we're just going to add the tops and keep the bottoms the same. So we're just going to have a denominator of x minus 4 times x plus 5. And we'll just combine our like terms up here. So we are just going to put these two together. So we're going to do 2x plus 3x is 5x. Negative 8 plus 15 is positive 7. And then we get this as our final single fraction. And if we did multiply the denominator out, right, we could just FOIL that, and we would have gotten x squared plus 1x minus 20. So what we're going to be doing with partial fraction decomposition is we're going to be starting here and going back to this. So we're going to try and find these fractions that we can split this back into, starting with the one fraction. So now this next screen is going to be a little bit overwhelming, so you can just pause it and either screenshot it or get it written down, and then I'm going to talk through it. But it's the whole process of what we're going to do. So the process is that you want to have the denominator factored, so we don't want to have it fully multiplied out. We want to be able to see the factors, because then what we're going to do in number 2 is split the factors apart. Okay, and if there is a factor that has a degree higher than 1, okay, then we need to factor with n minus 1, n. So what this means is if you have a factor in the denominator that's maybe like x minus 2 cubed, so it's that same factor there 3 times, then we're going to need to write it out when we split these fractions, and I'll show you an example of this. We're going to need to write this out as x minus 2 to the third, x minus 2 squared, and x minus 2, which would be to the first. So doing 3, 2, 1, if you have factors that have a multiplicity. Okay, and again, I'll show you all of this, but then we're going to put linear factors on top of anything. If we have a linear factor, we're going to put a constant on top of it. Okay, any letter, I'm just calling it a. If we have a quadratic factor, then we're going to put ax plus b, or bx plus c, or cx plus d. These are interchangeable, so you can change these constants. If it's cubic, we're going to put a quadratic above it, okay, and etc. So if you had an x to the fourth, you would put a cubed above it. Then we're going to set the original rational function equal to those partial fractions, multiply by the LCD, group it together, and solve with matrices. Okay, so I know this doesn't make a lot of sense written out like this, so let's take a look at a couple examples. So in these ones, I don't want you to actually do the whole process. We're just going to factor the denominator and write out the partial fractions. Okay, we're not actually going to solve them. So all I want you to do is factor this denominator. So what are the factors of negative 20 that add to positive 1? So that's going to be x plus 5 and x minus 4. Maybe you remember this from our first example. It was our first example. So then the next step is actually writing these factors out. So this is just a single factor. Okay, each one is a single factor. So we'll just write them each out as the denominator. Oops, that should be a plus 5. Okay, as the denominator of our partial fractions. Then above these is where we write out the constants or the linear or the quadratic. So this is a linear function, okay, or a linear factor because it's an x to the first polynomial. So above this, we're just going to have a constant. So I'm just going to write a. And then above this one, we're going to have a constant as well since it's linear. We can't use a because we already used it here. So this one, we're going to write b. And if you had more, you could write C, D, E, whatever, however many you needed. And then we're going to stop there because we're not going to solve. So this is just writing out the partial fractions. Okay, this isn't actually decomposing it and solving it, just writing out the partial fractions. So then in this next one, okay, again, the first step is to factor the denominator. So we see that all of these have an x cubed in common. So we'll take an x cubed out and we'll be left with an x squared, a minus 3x to the first, and a minus 10. So then we need to factor further. So factors of negative 10 that add to negative 3 are negative 5 and positive 2. So now we're going to have to write this out, okay? And what we have here, and this is where people get quite confused, is that this factor right here is actually a linear factor 3 times. So this is actually x times x times x. So it is, in fact, a linear factor that is there 3 times. So this one has a multiplicity. So this is where we're going to have to write this factor out as x cubed, x squared, and then x. So we're going to write it out in decreasing exponents. So x cubed, x squared, and x. Then we'll take the other factors. We still have 2 more factors. So we also have this x minus 5, and we have the x plus 2. So now you're going to put the constants above it. So now remember, this is a linear factor, okay, and we're just dealing with it with that it was there 3 times. So this is actually a linear factor. So above it, we're still going to have a. This is a linear factor. Okay, so above it, we're going to have a constant, 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 constant. Okay, so this is where people generally get confused, is it feels like this should be a cubic. So what a cubic would look like is if you had something like this, x cubed plus 2, and then if that, that would be a cubic factor, versus something like this, x plus 2 to the third is a linear factor to the third power. It is a linear factor there 3 times. So this one would get written under 1 denominator. This one would get written under 3 denominators. You'd have the x plus 2 to the third, x plus 2 to the second, and the x plus 2. So let's take a look, because we're gonna look into this more in the next video where we get these kind of more complex denominators. We're gonna be focusing on ones like this. So let's actually do the whole process. So again, the first thing you're gonna do is factor the denominator. Okay, so factors of positive 3 that add to negative 4 are negative 3 and negative 1. So then we will write this out. Okay, we'll actually write out the partial fractions. So we have x minus 3 under one denominator, x minus 1 under the other. Then above that, that's a linear factor, so we're going to put a constant of a, and a linear factor of x minus 1 is going to get a constant of b on top of it. So now the next step was to set it equal to the original, which I just did in my work. Okay, like I just put the equal sign with this original, so set it equal to the original. Next step is to multiply by the LCD, which should be your factored denominator. Okay, so this factored denominator is what you should multiply by. So now you're going to multiply this into every piece. Okay, so we're going to multiply this into here and get x minus 3 times x minus 1. Multiply it in here. Okay, and multiply it in here. Then you can cross out any common factors. So x minus 3 cancels, x minus 1 cancels. So on this first part, we're just left with 3x plus 7. On this next one, the x minus 3 cancels. So we're left with a times x minus 1. On this one, the x minus 1 cancels. So we have that plus b times x minus 3. So now is where we're going to multiply this out and actually get into the solving. So we have this 3x plus 7 on the left. Multiply the a in, and you have ax minus a plus bx minus 3b. And we just distribute these in. So now what we need to do is group these terms because we don't have any, we sort of have like terms over here. We've got the x's, okay, and then these ones are the constants. We want to match them up with this left side. So what we want to do is take a look at the 3x, okay, and we know that the 3x has to be equal to the ax plus the bx because those are our x terms. So we know 3x equals ax plus bx. And then same with this constant, the 7 is going to be equal to your constant terms. Okay, so the minus a minus 3b. So then what we're going to do is we're going to create a matrix here. And the matrix, so that we can simplify it, remember we want, when we do our matrices, for these to be on the right-hand side instead of the left-hand side. Okay, so we want this to be, to say equals 3, like ax plus bx equals 3x instead, and negative a minus 3b equals 7. So we always want those constants on the right-hand side. Okay, and so now what you're going to do is you're just going to take the coefficients of these. So the 1, we have 1 ax, 1 bx, 3x. Okay, so these are your a's, your b's, and your numbers. So you have 1, 1, 3. Then in this bottom equation, we have negative 1, negative 3, 7. So negative 1, negative 3, 7. And that's your matrix. So these were your A coefficients, your B coefficients, and then the constants that they were equal to. So now you're going to go into Desmos. Okay, so go to your Desmos calculator. So go to desmos.com and then go to Math Tools and Matrix Calculator and type this in. So you have a 2 by 3 and you have 1, whoops. Okay, so you have 1, 1, 3, and then negative 1, negative 3, 7. And then do RREF of matrix A, and this will solve it. Okay, so this will solve it. So you have 8 and negative 5. So let me just get that written down on here. So when we simplified this, we had 8, and then we had negative 5. So remember, this first column was the A, so this is saying that A equals 8, and this bottom one is saying that B equals negative 5. So these are our coefficients that we solved for from this partial fraction that we wrote. So the partial fraction that we wrote said A over x minus 3 plus B over x minus 1, and now we can just plug these constants in. So now we have 8 over the x minus 3, and then this B is negative 8. So we're going to put the minus in instead of a plus, or sorry, negative 5. So we're going to put the minus in instead of the plus and then put that 5. So that you can see this, let me put a little bit of color here. So this A was 8, so we put that in here. And then this B was negative 5. So we put the negative and then the 5. And then that's your final answer. So let's look at one more example. Okay, so again, let's factor this denominator. So for 2, we're going to have 2x and 1x. And then for 3, it's going to have to be a 3 and a 1. Okay, and we're going to want it to add to 5. So I'm going to put the 3 here and the 1 here because that'll give me 3x. And that'll give me 2x, which will total 5x for the middle. So 2x plus 3 and x plus 1 is what that denominator factors to. So then write out your partial fractions with those factors on the denominator. So 2x plus 3 and then x plus 1. Both of those are linear denominators, so they're going to have constants above them. So a, b. Then you're going to want to multiply by the least common denominator, okay, which again should be the same as your factored denominator. So we're going to multiply by 2x plus 3 and x plus 1 to everything. So multiply that in and you get 2x plus 3, x plus 1, 2x plus 3, x plus 1, and then 2x plus 3 and x plus 1 times that b. Cross out common factors top to bottom. So this 2x plus 3 and the 2x plus 3, the x plus 1 and x plus 1. So in this first one, you're just left with the numerator, 4x plus 2. The 2x plus 3 and the 2x plus 3 will cancel here. So you're left with a and x plus 1. X plus 1 and x plus 1 in that last one. So you're left with b times 2x plus 3. So now simplify by expanding the right. Okay, so multiply that a in, so you get ax plus a, multiply the b in, so you get 2bx plus 3b. Now you want to match them up, so you want to put the 4x and what that's equal to, so what terms have x's in it. So the ax and the 2bx would have to add up to 4x. Then you're going to do it with the constant. Okay, so which ones don't have x's with them? So 2 would have to be equal to a plus 3b. So now we're going to want to write out a matrix. So again, remember that we want what it's equal to be on the right-hand side. So I'm just going to move this 4x over, and I'm going to move this 2 over. Then you're going to write out your matrix using just the constants. So there's a 1ax, so this is a 1. It's a 2bx, so this will be a 2, and then a 4x. Bottom will be a 1a, so just 1, 3b, and then a 2. So then you're going to want to go back to Desmos. And you can just clear this out, or you can do a different matrix. So I'm just going to do a new matrix to show you what happens. It just labels it B. So then you're just going to type in 1, 2, 4, and then 1, 3, 2, and hit enter. So now when I do RREF, I want to do RREF of matrix B because that's what I'm working with. And then you'll get your solved matrix here, your row reduced echelon form. So we have 8 and negative 2. So we had 1, 0, 8, 0, 1, negative 2. And then these are our answers for our A and our B. So A equals 8, B equals negative 2. So if we remember back to what our partial fractions were, it was A over 2x plus 3 and b over x plus 1. So we'll just plug these in. So a is going to be 8 and b is going to be -2. So we'll have 8 over 2x plus 3, and then the b is a negative, so we'll put the negative here, 2 over x plus 1, and you get what your partial fraction decomposition is. So this right here is your final answer.